So we've taken a lot of time in looking at numerical data, trying to find the center of data sets, and we've done that in really two ways. We've looked at the median, which is essentially the middle number in the data set when you put it in order, and we've looked at the mean, which takes into account every single data value when trying to measure that center. Now we've also try to measure how spread out data sets are, or how much variation there is, through the interquartile range. And measuring how spread out a data set is actually going to be pretty important to us throughout this course. So the interquartile range, though, remember, only took into account two values, the 75th percentile and the 25th percentile. So it might be nice to have a measure of center that takes into account every single number in the data set. And so that's what this thing is, the standard deviation. All right, so the word deviation, first of all, is referring to how far a number is from the average of the data set. So when you see deviation, that means the data value minus the mean. That's what the deviation is. And so the standard deviation is a way of kind of collecting all the deviations and giving it kind of a sense of the overall deviation in a sense. So as we go along, this formula and this concept of the standard deviation will kind of gain more and more meaning. But first, let's just focus on, how do we actually do the computation? So first of all, you'll notice that the sample mean is in this formula. So we definitely need to find that for our data set. So for this example, let's go ahead and just do that. 6 plus 10 plus 13 plus 11 plus 12 plus 8. And there are 6 values in this data set, so I'll divide by 6, and that gives me 10. Now, looking at this formula, if you remember, perhaps a long time ago for you, is that when you have lots of things to do in a formula, you should follow the order of operations. And remember, P stands for parentheses in the little acronym PEMDAS. And we have parentheses. So what I kind of like to do is to make a little table. So I'm going to go through each one of the values and compute its deviation from average. So I'll start with 6 minus 10. That gives me negative 4. 10 minus 10 is 0. 13 minus 10 is 3. 11 minus 10 is 1. 12 minus 10 is 2. And then finally 8 minus 10 is negative 2. Now you might remember that the second step in the process of the order of operations is E for exponents, and we have an exponent, right? We have this square here. So the next thing we want to do is go through and take all those numbers and square them. So remember that when you square a negative, it gives you a positive. So negative 4 squared is positive 16. 0 squared, of course, is 0. 3 squared is 9. 1 squared is 1. 2 squared is 4. And negative 2 squared is 4. All right. Now what we have here is, remember, this symbol here means the sum, or to add. And so we have a whole bunch of things added on the top of a fraction, and then we're going to divide by 1 less than the sample size. So anytime you're adding a bunch of the things on the top of a fraction, you do those things first. So the next step then is to add up all those deviations squared. So it'll be 16 plus 0 plus 9 plus 1 plus 4 plus 4. And when you add all that up, you end up with 34. And then I need to take that and divide it by 1 less than my sample size. So my sample size is 6, so that means 34 over 6 minus 1 is 34 over 5, which gives me 6.8. And then lastly, we've got the square root over all of this. So my sample standard deviation is the square root of that number we just came up with. Oops. So we've got the square root of 6.8, and that gives me approximately 2.61. Now, this all by itself, what does this mean? Well, we kind of need some more experience with the standard deviation to really start to get a handle on what it means. But for now, what we could say is this. This has a standard deviation of 2.61. If I had another data set that had a standard deviation of 6, my other data set would be much more spread out than this one. There'd be a lot more variation in the numbers. They're much further from average overall. So what we definitely can do with this number is compare it to other data sets to be able to determine which one has more spread to it. Now that process that we just went through was kind of tedious, right? And so if the data set gets much larger than that, I'm never going to want you to have to do that manually. So I want to show you how to use technology to not only do the standard deviation, but other things as well. So in example 20 here, it says, use your calculator to find the mean, the median, and the standard deviation of the following data set. Also create a box plot. So I've asked you to do a lot of stuff here, but it turns out one command in your calculator is going to give it all to you. The data set, and I guess I should have a capital T here, right? The data set gives the waiting time in seconds between ordering and receiving coffee for 20 customers. All right, so big data set here. I'm not interested in applying that formula on the previous page to all those numbers. So in our calculator, what we'll do is first go find the stat button. And the stat button is right next to these arrows here. So I'm going to hit stat. And then I'm going to select edit, which is the first thing that will be selected. And then this gives me a place where I can list numbers. Now, let's just for a second, I'm going to type in a couple of numbers that aren't in this data set. I'm just going to do this. 1, 2, 3. Okay. So if you happen to have numbers already in your calculator, especially if you're renting a calculator and it was someone else's before, then to get rid of them, go up to the title. So in my case, L1 for list 1. Select clear, and then select enter, and that'll zap out the whole list. Avoid using delete because that'll get rid of the entire column. Just highlight the title and hit clear. All right, so now I'm going to type in all these data sets under list 1, and I'm just going to press enter after each one. So 40, 60, 70. And just get this entire thing typed in. It wouldn't be a bad idea for you to just kind of follow along with me so that in your calculator you kind of get used to where everything is. And when you're typing these in, at the end you should always kind of take a look back through, make sure you didn't make any typos, because if you did and you don't notice it, you're going to get wildly different answers and really wonder why. Alright, so I can kind of scroll back through here, make sure these numbers seem reasonable. I didn't type any extra zeros on accident or anything like that. Alright, so I've typed all that in. Now to get back to your home screen, you can hit second quit, and then that'll just take you back to the main screen on your calculator. Now to actually have our calculator compute all of these things it asked for us, we're going to go back to stat again, but now you're going to toggle over to calc, and you're going to select one variable statistics. Okay. Now some of you will see this screen right here, others of you will not. So if you see this screen in your calculator, then you can go ahead and First of all, make sure your list says list 1. Make sure that this frequency list is empty. So now let's suppose that either the list is empty or maybe it says something else. Then the way you make it say list 1 is, notice L1 is the second function of the number 1. So I just hit second L1 and that puts it in that list. And then again, frequency list is blank, and then you hit calculate. Now if your calculator didn't have that screen that I had that allowed me to type in my lists, what you probably saw instead of all of this was, get rid of this, just one variable stats all by itself. If that's what you saw on your calculator screen, just go ahead and hit enter and you'll get the same numbers that I see on mine. All right, so we can see from here, X bar, right? We are using the same symbol as our calculator for the sample mean is 117.25 seconds. My standard deviation is this S right here. So S with little x, that's my sample standard deviation, 42.6. There's always going to be this one right below it that is very close to your standard deviation, so just always make sure you're grabbing the one with the S. So 42.6 seconds. And then it asks for a median and the box plot. So to find that, we just scroll down, and you'll notice right here is our 5-number summary. The minimum is the low, the max is the high, and then we have our quartiles right here. So the median, I'll go ahead and put right here, is 115 seconds. And then to make a box plot, I can see that I need to range between 40 and 200. So we'll start here at 40, and I don't know, maybe count up by 20s might be reasonable to get ourselves up to 200. So 60, 80, 100, 120, 140, 160, 180, and 200. Oops. Oh. All right, and so now I can put in my box plot, so I definitely have a minimum of 40, and it's going to go up to 87.5. Puts me right about there. And there's the left part of my box. Then I'm up at 115, which, you know, maybe puts me right about there. And then the third quartile is 150, which puts me there. And then that extends up all the way to 200. All right, so we were able to pretty quickly get a lot of information from this data set just by letting technology help us. For the most part, in all of my homework, it usually tells you, you know, whether to use your calculator functions or to do it manually. But you can just bet, even if I forgot to tell you somewhere, if it's a data set that's got more than 10 data values in it, I'm going to never want you to compute something like standard deviation manually. So at that point, you just pull out your calculator to get that information. All right, so now to kind of provide some meaning to this idea of standard deviation, let's look at this example. It says, suppose that I gave two different tests that both had a mean score of 76%. Suppose that test 1 had a standard deviation of 13 and test 2 had a standard deviation of 7. Okay, so to kind of organize this here, here's test 1, test 2, same averages for both, right? 76 for both of these tests. Standard deviation for test 1, though, is 13. Standard deviation for test 2 is 7. So the question is, which one likely had more A grades? All right, so let's think about that a moment. More A grades. Well, first of all, this is a C, right? C to a C plus kind of a grade, right? Okay, so an A would be significantly above this. So based on these standard deviations, can we tell which of these two tests likely generated more A grades? Well, we do know that test 1 has more variation, more deviation from the average. So what we would say here is that test 1, we don't have a lot of information to go off of, but we can say that it's most likely that test 1 had more A grades because it has more deviation from the average. Or another way of saying it is that the data is more spread out. So more spread means you're going to have more on the extremes, and an A grade is more extreme because it's up in the the 90% range. And then which of the tests likely had more C grades? Well, that'd probably be test 2, right? Right? Test 2 had more C grades because it has less deviation from the average. Or in other words, it is less spread out. Okay, so you can see how this idea of standard deviation can help us understand the comparison of two data sets, right? We can actually get some kind of practical meanings from just that one single number alone when we compare it to the standard deviation in another data set. All right, lastly, I'd like to show how we can get things like the average and standard deviation from a frequency table. We've looked at frequency tables before, and we're going to use technology to do this. So here what we have is the number of credit hours a sample of 25 full-time students are taking this quarter, and it's summarized here. So 12 credits, there's 5 students, 13 credits, there's 7 students, and so on. All right, so on our calculator, clear that out. We're going to go back into stat, and then we're going to go to edit again. And first of all, let's get rid of our old data set. So again, we highlight the title of the list, we hit clear, we hit enter, and that'll zap out all of those old pieces of data. So now I'm just going to type in my variable values into list 1. So 12, 13, 14, 15, and 16. And then in list 2, I'm going to type in the frequencies that each of those values occur at. So there are 5 12s, 7 13s, 6 14s, 4 15s, and 3 16s. So we're going to do this similarly to the last time we used our calculator. We'll go to stat and then calc. And we're still going to pick one variable, stats, but now the difference is list 1 contains my variable values, so I want list 1 as my list, but now I have a frequency list. So we need to tell the calculator that the frequency list is in list 2. Now if you don't have this this screen on your calculator right now, just hang tight for a moment and I'll show you how to work it on yours. But once you type that, you'll hit calculate, and we get all this information. Okay. Now, if you didn't have that screen, what is going to happen is, let me make it look like what you'll see, is you'll just see one var stats on your home screen after you hit enter. So what you have to do now is you need to tell the calculator what list to find the variable in and what list to find the frequency list in. So you first type where the variable's at, list 1. You type a comma, which is right above your 7, and then you type the list that your frequencies are in, and then in our case list 2. So once you type those, then you can press enter, and then you'll get the same thing that I got before. All right, so it just asks for the mean and the standard deviation here. So our mean is 13.72 credits with a standard deviation of 1.31 credits. And if I ever give you a frequency list, even if it's nice and short like this one, I'm fine with you just going straight to the calculator with that, even if it's not a very big list. Just don't want to take a lot of time doing all the manual calculations for standard deviation for a frequency list.